For decades, the geometry of strategic nuclear deterrence was defined by two dominant arsenals and a much smaller, deliberately opaque Chinese force that promised never to strike first. That geometry is now being redrawn beneath the deserts of Gansu and Xinjiang. A quiet but relentless construction campaign has added hundreds of new solid-fuel missile silos, while the People's Liberation Army Rocket Force loads canisterized ICBMs that can fire in minutes instead of hours. At the same time, Beijing's official rhetoric still holds the line on a no-first-use doctrine, even as its deployed hardware increasingly mirrors the posture of nations that reserve the right to launch on warning. Today, we move beyond headlines and satellite snapshots to examine the physics, the infrastructure, and the command and control timelines that are reshaping China's nuclear identity, and with it, the stability of the entire strategic balance. The shift from liquid-fueled DF-5 missiles to solid-fueled DF-41 and DF-31 systems inside the new silo fields eliminates the hazardous hours-long fueling process that once generated unambiguous thermal signatures detectable by Western space-based sensors. Solid propellant missiles are stored in a fully fueled state, allowing them to proceed from launch order to ignition within minutes rather than hours. The DF-41's canisterized design and pre-aligned inertial navigation systems enable a rapid ejection and ignition sequence. Silo designs observed at Jilantai lack the large exhaust vents characteristic of hot launch systems, suggesting a possible cold launch or gas ejection mechanism similar to Russian designs, though Beijing has not released technical specifications. Crucially, while solid fuel provides the technical readiness required for a launch on warning posture, propellant chemistry alone is insufficient. Such a doctrine strictly demands a highly integrated early warning architecture, combining space-based infrared sensors with over-the-horizon radars, a capability China is actively maturing, but whose operational integration remains highly classified. Satellite imagery analysis from open-source intelligence agencies has identified a massive infrastructure expansion across the Yumen, Hami, and Ordos fields, constructing an estimated 250 to 320 new deep Earth silos, depending on the inclusion of training and support sites. When combined with legacy DF-5 installations, China's total silo-based launcher inventory approaches roughly 280 to 340 units. The Pentagon's December 2025 draft report confirmed that well over 100 solid-fuel DF-31 ICBMs have already been loaded across these fields, leaving a substantial portion of the infrastructure empty or occupied by decoys. During the construction phase, massive inflatable environmental shelters served a dual purpose, curing high-strength concrete in sub-zero desert temperatures and concealing subsurface structural activity from visual and infrared satellite tracking. This deliberate overbuilding creates a strategic shell game, forcing an adversary to allocate warheads to every verified silo location to ensure destruction, and thereby saturating enemy counterforce strike assets with uncertainty. The land leg currently dominates China's strategic modernization, with an expanding force of silo-based launchers alongside highly survivable road-mobile transporter erector launchers, putting Beijing on track to scale its warhead inventory beyond 1,000 by 2030. The sea leg is advancing in parallel. while continuous at-sea deterrence patrols remain unconfirmed for the older Type 094 SSBN. Satellite imagery from November 2023 at the Huludao shipyard shows pressure hull sections of the next-generation Type 096 SSBN already under early construction, with the lead boat anticipated to launch within approximately 1 year and carry the MIRV-capable JL-3 missile. The air leg remains the weakest component, reliant on the aging H-6N bomber carrying air-launched ballistic missiles, while the stealthy H-20 strategic bomber has yet to achieve confirmed flight testing as of early 2026. The scale of this modernization marks a definitive transition from historical minimal deterrence toward a limited deterrence, the term used in Chinese strategic literature, approaching strategic parity with the United States and Russia. Officially, Beijing maintains a strict no-first-use policy. However, the deployment of these survivable, fast-reacting assets introduces an intentional doctrinal ambiguity that is functionally indistinguishable from the technical prerequisites of a launch-on-warning stance.
Transitioning toward a rapid response posture severely compresses the decision-making timeline for strategic command nodes. Should an incoming strike be detected, analysts estimate the entire verification sequence, from initial space-based infrared detection and over-the-horizon radar confirmation to senior leadership assessment and weapon ignition, could compress to well under 15 minutes. This tightly coupled timeline eliminates the historical ride-out buffer, where leadership could afford to wait out an attack to verify its authenticity, forcing an irreversible launch before the first incoming warhead detonates. The compression drastically escalates the risk of catastrophic miscalculation, as demonstrated by the 1983 Soviet false alarm incident, where only a human override prevented retaliatory launch based on a satellite sensor glitch. China's early warning network, built around P-band and over-the-horizon radars, features less operational redundancy than legacy American or Russian networks, raising the probability that sensor anomalies or atmospheric disturbances could generate ambiguous threat signatures. Furthermore, any conventional strike intended to disrupt regional command and control infrastructure could be misinterpreted by automated decision support algorithms as a strategic decapitation attempt, triggering an unintended nuclear escalation from an unverified alarm within minutes. China's deployed nuclear infrastructure now presents a reality that its declaratory doctrine has yet to fully acknowledge. The physics of solid fuel readiness, the architecture of the silo fields, and the integration of a maturing early warning network have collectively built the technical chassis for a launch-on-warning posture, regardless of whether Beijing officially embraces the term. This gap between capability and declared intent creates a deliberate strategic opacity, one that complicates adversary decision-making, but also injects profound instability into crisis scenarios where minutes determine outcomes. The compressed timeline, fragile sensor redundancy, and the looming risk of automated misinterpretation form a volatile equation that no diplomatic white paper can neutralize. China's nuclear modernization has not simply expanded a deterrent, it has rewritten the temporal and psychological grammar of escalation in the Indo-Pacific and beyond. Without enhanced transparency, verified restraint, and robust crisis communication channels, the world now operates in a strategic environment where a sensor glitch, a conventional strike, or a misinterpreted radar return could cascade into nuclear use before the error is even detected.